All right, how's everyone doing? Today's video would be to continue from where we stopped. If you remember, we began to look at hypothesis testing, and we explained the concept all the way to the very end. And we said it's about a 6 to 7 step process, all the way from setting up your A sub O and A sub A to making an interpretation. In the last video, we showed you how to solve hypothesis testing when the population standard deviation is known. And we showed that in that scenario, for solving your test stat, you use z-values or z-test. Well, in most cases, you don't know what the population standard deviation is. And when you're faced with that scenario, you tend to use what we call a t-stat or t-values. In this video, I'm going to walk you through the process of solving questions where the population standard deviation is unknown. And just like the first video, where we did 3 examples, to the left, to the right, and 2-tailed test, in this video, we're also going to do the same thing. We're going to look at how to solve these questions, looking at it from the point of view of a left-tailed test, a right-tailed test, and a 2-tailed test. By the end of this class today, you will be comfortable solving questions when the population standard deviation is unknown. So go to your module, grab your Excel, and follow along with me as I solve these questions. We're going to tackle questions for example 3, example 4, and example 7, right? And we'll walk through the whole process with you. All right. But before we begin, let's make some, let's clarify some things, right? Usually when you have population standard deviation, you tend to use z-test. But when you have a sample standard deviation, or when a population standard deviation is not given, we use what we call a t-test, right? The t-test was actually meant for small values. And that's why we tend to use the t-test when your sample size is also less than 30. But the most important thing to remember is that you are basing it on having the population standard deviation given, or if it's not given. Other than that, most of the steps is the same or are the same like what we did in the last video, with one difference. Now, the test stat uses what we call a degrees of freedom. One way to understand this is to solve with a t-test, you need to find out how many numbers, right, or sample size are truly free. Now, usually in any given scenario, right, for one set of data, only one value is not free, right? A simple example is if I give you a box, give you a box or 3 boxes, and I say it's equal to 25. And I say you should select any number you want, any number, right? Let's be fair. You can select 8, right? That's your choice. You can select, I don't know, maybe 12. That's your choice. But this third number, you don't have a choice. 5, because 8 times 12 is 20. And to get a 25, the only way is to have what? 5. This number is not free. So you have 2 free numbers and 1 number that is not free. And so this is what? 3 numbers minus what? 1, which shows you 2 free numbers and 1 that number is not free. So the degrees of freedom is usually n minus 1. Just like you saw, I would say 3 minus 1, same thing, 3 minus 1, 2. So these are the free numbers to use. That's the key difference between using a t-test and a z-value. Another difference is that when you're doing your test stats, if you remember, when we did for z-values, we said your sample mean minus your population mean over standard deviation, population standard deviation, what is greater than n. In this one, remember, we don't have this. We don't have this. We don't have the population standard deviation. And so what we tend to do is we use what? A sample standard deviation of what is greater than n. That's the the two key differences between what we did in the last video and what we're going to do today, right? We're going to use sample standard deviation instead of population standard deviation. That's 1. 2, we're going to, in calculating our t-stat, our t-test, sorry, we're going to use degrees of freedom, which is n-1, to help us do that. Now, I hope this makes sense. If it doesn't make sense, don't worry. We're going to solve at least 3 questions. And by the time we're done with these questions, I guarantee you that this would make sense since you've watched the video prior. And so this will follow along in that light. All right, let's have some fun. All right, I'm going to start with this question. So this question is actually pretty cool. It says that Allstate, right, insurance company, they reported that the mean cost to process a claim is $60, right? So our industry comparison showed that the amount is higher or larger than most insurance companies. So the company now instituted some cost-cutting measures, right? Now, after they've done that, right, they want to evaluate the effect of the cost-cutting measures, right? And so the supervisor of claims department randomly selected 26 claims processed last month. And the records of those 26 are shown below, right? And so now we're now told that the sample information is reported in the following table. So we're now told at 1% significant level, is it reasonable to conclude that the mean cost to process the claim is less than $60? Remember, this insurance company processes its claim for about $60. It now came up with ways to reduce that cost because that's higher than most insurance companies. So after carrying out a few cost-cutting measures, it now wants to test to see if those measures worked. So now what they did was they selected randomly 26 claims. And so now we want to see if the mean cost to process a claim is less than what? $60. That's what we are trying to find, right? So let's start with the first step. The first step is we want to write down what we know, right? Let's start with from what we know. So let's go to sample size. I always tell students that I would encourage you to count this, right? Let's count and see how many we have here. That's our sample size, right? So that's 26, all right. And what's our level of significance? Our level of significance is 0.01, so 1%. All right. The next thing is what's our population mean? That's easy, right? Because it's tied to what we're being asked. Claim is less than what, $60. So that's our claim. So we know that's going to be 60. You can put $60 if you want to. All right. So what's our sample mean? Now, our sample mean is not given, right? But we're giving a bunch of samples, so we can find our sample mean easily, right? We're just going to find the average of those values. That will give us a sample mean. So we go here and we find the average. And so we got that, right? That's our sample mean right there. Okay, but what about standard deviation? The reason why this question is going to be done with t-test instead of a z-test is because this question does not provide us a population standard deviation. Now, on the secondary part, yes, the sample size is less than 30, but the most important thing is that it doesn't provide us with a population standard deviation. So that tells us that we're going to use a t-test, right, to solve the question. And so we're going to say our sample standard deviation is going to be equal to standard deviation. We're going to select sample, right? And then we'll select the values. Right. So now that we have these values, right? And remember, you can always turn these values into dollar terms so that it follows the key concepts of what we're doing, right? You can do that, and that's fine. And this is money, so you can always leave them into decimal places. All right. So what we're going to do is our step 1. Remember, our first step, it doesn't change. It's the same. We have to write our 8s of O and 8s of A. If you remember what we said that this is always about equality. And then this is always about inequality. And if you see, it says to process a claim is now less than 60. Less than 60 is this. So we're going to come here and we're now going to say H sub A, right? Population mean is less than $60, right? We know that because it says less than, and less than usually is attached to H sub A. And then H sub O is basically going to be the opposite, right? And we know that because the opposite here is greater than or equal to. So we'll say is greater than or equal to $60, right? So we've done our first step. Our second step is already given here, right? So you can see so far, nothing has changed, right? We're still following the same step. Now, step 3 is to talk about what the test stat is, and the type of test it is. And we know that this is less than sign. Less than sign, as you all know, it's a left tail test. All right. So we've gotten to the fourth part. Pretty much similar, right? Now we just need to find our test statistic. And it's the same process. The only difference now is that we're doing sample mean minus population mean over sample standard deviation over square root of n. And like I said, you can do it in 2 steps, right? Difference in mean, standard error, and then divide, right? So let me just do that for the first one so you can see that there's no difference. So sample mean minus population, right? And then this one will now do our sample standard deviation divided by the square root of our sample size, right? So now to find our test stat would now be equal to this value divided by this value, right? So you can see that we got our test stat. The one thing we haven't added is our degrees of freedom. Remember, our degrees of freedom is n minus 1. So that was n minus 1. We get our 25. All right. So now we've gotten to our step 5. Now, when we're solving questions involving test, we're going to use critical value, right, to solve the question. Now, to do our critical value, we need to know 2 things. We need to know what type of test it is, and we need to also know what our level of significance and degrees of freedom are. So let's write that again. So we know that this is a left tail test, right? A left tail test, right? We also know that our level of significance is 0.01. So I'm just going to copy that here, just put it right here, right? And the third thing is that we know our degrees of freedom is 25. So we got all our values here, right? 25. All right. So now that we have our values, we can now find our critical value, right? And it's actually going to be equal to T dot inverse. Remember when we're doing for the other ones, we use norm dot inverse because we're doing for a Z value, so we use normal distribution. So normal inverse. For t-test, we're going to use T inverse. So we're doing the inverse because we're trying to convert probability into T values. And so you select your T inverse, you now select the probability, and there you now select the degrees of freedom, right? And you press enter. So you can see it gives you negative 2.285. The trick here now is just to draw. So remember your critical value, right? We did. It's saying that 2.485. So it means that anything here, it fails to reject A sub O, or anything here, it rejects A sub O. Right? So take this as your negative, your critical value, right? Now let's look at our test stat. Our test stat is what? Negative 1.817, right? And that falls right here, right? This is our test stat. as negative 1.817. You can see, right, it falls in the fail to reject region. So our decision here would be, since T stat falls in the fail to reject region, we fail to reject 8 sub O. So what is 8 sub O that we're failing to reject? 8 sub O is saying that population mean is greater than or equal to 60. We fail to reject that. So what that's sad, right? Because that means that all the cost-cutting measures that the company has used has not reduced the cost. So the cost is still equal to or greater than 60. The question is it reasonable to conclude that the mean cost to process a claim is less than 60? No, right? And so sadly, our interpretation here, right, is that at 1% level of significance, we do not have sufficient evidence, right, to conclude, right, that the mean cost to process a claim is now less than 60. If we rejected 8 sub O, then we would have had enough. We would have said, oh yeah, they've worked, it's worked. Obviously, whatever they've done is not good enough, right? The claim, we're seeing that it's still 60 or more. So the company will need to go back and make some more changes or cuts, right, to the process. You can see, right? It's similar, right? Everything is the same way, just a few changes, right? We have a degrees of freedom. We have to get our critical value using the T test. But other than that, the entire process seems the same. All right. Now, let's try an example. This was a left tail test, right? So let's try if the question is asking for a right tail test. So we'll try question 4. Now, I hope this is beginning to make some sense because we're trying to make this as easy as possible. Let's look at question 4. Here, LAX, right, has a short-term parking close to the terminal. So someone meeting an incoming passenger has only a short walk to the baggage claim area, a good place to meet. To decide if the short-term lot has enough parking places, the manager of airport parking needs to know if the mean time in the parking is more than 40 minutes, right? You want to know if the mean time is more than 40 minutes. To do that, they sampled 12 customers, right? And try to see how long it takes for them, right? And they found out these results, right? Now, the question is, at 5% level of significance, is it reasonable to conclude that the mean time in the lot is more than 40 minutes, right? So we're going to see that, right? We're going to try to see if we can conclude that the mean time in the parking lot is more than 40 minutes. So just like we did in the past one, right? We have to lay out what we know and then look at what we don't know. First of all, this question doesn't give us a population standard deviation. That just tells you that you're going to do t-tests, right? And so that's the first thing you want to always see. So let's do a count and see how many, what the sample size is. Sample size is 12. And the population mean, we know that because the question, right, tells us, is it reasonable to conclude that the mean time in the lot is what? More than 40 minutes. So we know that that's the population. Remember, the whole essence here is to prove or unprove what the population mean is, or the population parameter is. So the question will always be about the population mean. That's how we know that. All right. Let's find the sample mean. The sample mean is not given, but we can find that, right? Because we're giving a sample we can just find the average of that sample. So we got that. The sample standard deviation is not given. That's why we know it's a t-test, right? And so we're just going to find the standard deviation, right? The degrees of freedom, right, is your n minus 1. All right. So I think we got everything, right? Level of significance is the one that we're missing, and we're told is 0.05. All right. So now let's start with the first step. Remember, the first step is to state A sub O and A sub A. But you can see, right, it says more than 40 minutes. Since this tells us clearly more than 40 minutes, that's easy, right? We know that H sub A, because that's where more than goes, right? So we'll say population mean is more than 40 minutes. By default, it then tells me that H sub O will be what? Less than or equal to. Right? So you can see that this becomes stable, right? You should know this by now. Step 2 is given to us. We know step 2 is given here, so we don't have to worry about step 2. Right there. Step 3, because it says more than, we know this is going to be what? A right-tailed test. So we got step 3. All right. So let's do step 4. Step 4, we're going to find the test start. Right? And remember the test start, right? Remember it's the difference in mean over difference in standard error. So we're going to say, okay, so the sample mean minus population mean, that's the difference. And then for the bottom, we're going to say sample standard deviation divided by the square root of the size. And so we get that. And that'll be equal to this value divided by this. So you can see we found our t-stat. Right? Let me make this a little bit larger so you can all see it. All right, so now we found our test stat, right? All right. So let me make it clear so we can see that. All right. So now step 5 is to find our critical value. Now remember, right, to do our critical value, right, we usually use our level of significance. We use that. That helps us. You don't have to copy and paste it here. You can just use it there. But I just want to make this kind of easy for you to grasp the concept. And we also know, oh, that's because I copied. I need to paste it this way. All right. And we also know that this is a right-tailed test. So we know very well that this starts from around 0 and goes all the way to almost 100, right? So 0.05 is going to give you left. We're looking for a right-tailed test. So we're going to find the opposite of this, right? And so in this scenario, it's going to be 1 minus what? 0.05, which gives you 0.95. So that's the part we're going to look. Remember, 0.05 is going to be on the left side, but this is a right-tailed test. So we have to look at it from the point of view of a right-tailed test. All right. So now to find out critical value, this would be equal to, we do our t inverse, right? And we'll put our 0.95 and then our degrees of freedom, which is 11. And that gives us 1.78, right? 1.80, right? Or 795, right? And so that just tells us that this is going to be somewhere here. 1.796, right? This is our critical value, right? And so we'll now look at our test stats. So you look at the test stats, it's 2.91, right? That's our test stat, 2.91. So it falls, so remember this is fail to reject. And this is the rejection part. So you can see that it falls in the rejection area. So because of that, so we're going to say decision. Since right? Test that falls in the rejection region. You can write that, you can say to the right of particular value. That's also correct. We reject A sub O. This is huge. When you say you reject A sub O, what you're saying is that you don't agree with this because you have enough evidence to prove that. And so that means that you agree with this one, right? So the interpretation here is, I remember the question is asking you is it reasonable to conclude that the mean lot time in the lot is more than 40 minutes? A sub A is more than 40 minutes. So we can say that at what's the percent? 5% level of significance, we have sufficient evidence to, right, conclude that the mean time in the lot is more than 40 minutes, right? Is it making sense? I hope it is, right? We've done the left tail test, we've done the right tail test. We're just doing it slightly different, but if you look at the steps, that pretty much the same, right? You can call this step 6 if you want, and then I can't even spell step 6, and we can say this is step 7, right? All right, I'm going to do one more. I'm going to try and show you guys a scenario where you have two-tailed tests. That way you will feel comfortable that we've covered every kind of question that you can ever see in an exam. So look at this one. This is example 7. It says that according to the local union president, the mean gross income of plumbers in the Salt Lake area follows a normal distribution. It has a mean of 45,000, a sample standard deviation, right? So that tells us clearly that we're going to use t-test, right? So we're told that the population mean is 45,000, right? We're told that the sample standard deviation, I'm just going to make this 3,000. We're told that the sample size is 25 plumbers, right? And we're told that the gross income was what? So that's our sample mean is 45,500, right? It now says at the 10% level, significance level, right? At 10%. The question is it reasonable to conclude that the mean income is not equal to? See when it says it's not equal to, right? So you just know that that's a two-tailed test. It's not equal to, it doesn't say greater than or less than, right? So we know that's a two-tailed test. So that means that H sub O, population mean, is equal to 45,000. And then for your H sub O or H sub A, the alternate will be the opposite, right? Is not equal to that. See, step 1, nice and easily done, right? Step 2, okay, what happened to step 2 here? Okay, it was 0.1. So let's go here and fix that. I think the system thinks that we're dealing, everything here is about money. So let's make sure that it knows it's not. All right. So this is step 2 right here. All right. Step 3, this since it's not equal to, remember, this just means H sub O, that the population mean is not equal to 45,000. Sorry, H sub A. H sub O means it's equal to 45,000. So we know that this is going to be what? A two-tailed test. That's step 3. Step 4 is we now find our test statistic. All right. But before we do that, we need to find our degrees of freedom, right? And remember, our degrees of freedom is going to be n minus 1. All right. So we can do it step by step, right? We're going to do the sample minus population for the top. For the bottom, we can do our standard deviation divided by the square root of 25. And then we just divide between the two of them. All right, until we get 0.8333. So that's our test stat. Now let's look at the critical value. Critical value, we know for one that this is a two-tailed test. We know that our number of significance is 0.10, and we know that our degrees of freedom is 24. Now there are two ways you can solve this question. I'll show you the two of them. Actually, it's one way, but there are two ways of looking at it. I can make if I'm running out of time, I can do it differently. I can say, okay, you know what, this is equal to t dot inverse, and I'll select 2t. So it's going to do it for two tails. Now it's going to give me a positive answer, but I will just know that that's going to be the same for the other side, just going to be a negative sign. So what you can do is you will just come here and say, okay, probability in this scenario is 0.10, right? And then degrees of freedom is 24. And so I get 1.97. So I can now say that means that the second one is going to be this same value, but it's going to be 1.71088, right? Now, this confuses students sometimes to remember that it's two sides. So another way to look at it is, well, how did we do that in the past? In the past, if we had 0.10 as our level of significance, remember what this means is this whole place is 90. But in theory, because alpha is 10, it has to be divided by 2, which means this is 5%, this is 5% to give you 100%. So in theory, these two places here is 5, and here is actually 95 because it's 5 plus 90, or it's 100 minus 5, so it's 95. So one way you can solve this question is say, okay, this is equal to your 10% level of significance divided by what? 2. That gives you 0.05. That means for the right side, it's going to be 1 minus this, which gives you, right? And now that you have the two percentages, you can now solve it, right? Because that's equal to t dot inverse. Select this and select 24. And then for this one, you're going to do equal to 17t dot inverse. Select this and select 24. You can see, right? You get the same answer. The same, right? So what it says here is, you know what? This is a two-tailed test. And so anything here, 1.71088, this is going to be our critical value. And then for here, critical value, we start at minus 1.71088. Right? Now, anything here, we're going to fail to reject. It's a O. Anything here, we're going to reject. It's a O. And anything here, we're going to reject. It's a O. Right? And so we now go back to look at our test stats, which is what? 0.8. 0.8. Remember, this is 0, right? So 0.8 will be somewhere here. Right? This is our test stat. And it's 0.8. So you can see it falls in the fail to reject area. So we're going to come here and say, okay, what's our decision? Right? So since test stat falls in the fail to reject region, we fail to reject this above. Remember, the goal here is it reasonable to conclude that the mean income of the plumbers, right, is not equal to 45? 8 of O says is equal to. 8 of A says it's not equal to. If you fail to reject A sub O, then that means that technically, that means that A sub O stays. Now you can argue that the reason is because you don't have enough evidence. That's true, but you weren't able to disprove A sub O. So what's going to be our interpretation? We'll now say at 10% level of significance, right? Because we do not have sufficient evidence, right, to conclude that the mean income is not equal to 45. Right? We don't have enough evidence to prove. If we rejected A sub O, then we'll go to A sub A, and A sub A is the one that says it's not equal to. But we weren't able to reject A sub O, so we don't have enough evidence to prove that it's not equal to. As it stands, it is equal to 45,000. That's the third example of hypothesis testing. We went through a left-tailed one, we went to a right-tailed one, and we concluded with a two-tailed one. I hope that with these three examples, this topic has become easy for you to understand. Remember, if you still have any questions, you're free, and I'm happy to have you in my office hours. Send me an email, and we'll help you walk through this process. But I hope this makes a lot of sense for you. Thank you for watching. And for extra credit, you would need to do questions 2, 5, and 6. So let me write it down. Extra credit will be question 2, 5, and 6. And you submit that on that classwork, right? So that you get credit. And that should be by Saturday of this week. All right. Thank you. And I hope this was helpful to you, for you, like it was for me. Take care.